ಹೇಳಿಲ್ವಾ?
ಅದು ಅವಳಿಗೆ
Hello.
ಬಯೋಟೆಕ್ ಸ್ಟಾರ್ಟ್ ಆಗಿದೆ, ಇನ್ಯಾರ್ದು ಆಗಿಲ್ಲಲ್ಲ?
Good morning all. We'll begin in a moment.
ಯಾರ್ಯಾರು ಕ್ಲಾಸ್ ಅವರೆಲ್ಲ
I request all the participants to mute yourselves. If you win without struggle, you are heading towards victory. But you win in spite of troubles, you are scripting history. The greatest thrill lies in breaking free of bondages and struggling to reach towards your goals. The greatest privilege is to inspire others and to set an example for them. Ladies and gentlemen, a very good morning and a warm welcome. Namaskara. The Anand Sagar College of Engineering is proud to welcome a very good morning and a warm welcome. Namaskara. The Anand Sagar College for the glitch. Once again, a very warm welcome to you all. The Anand Sagar College of Engineering is proud to welcome honorable dignitaries, invitees, faculty members, and students to the inauguration of the 3-day virtual international conference on applications of artificial intelligence and computational mathematics 2020. I am privileged to welcome today our chief patrons, Dr. D. Hemachandra Sagar, Chairman, the Anand Sagar Institutions, Dr. D. Premachandra Sagar, Vice Chairman, Dayanand Sagar Institutions, and Sri Gali Swami, Secretary, Dayanand Sagar Institutions. I would like to extend my warm welcome to today's distinguished chief guest, Dr. K.N. Balasubramanyamurthy, Vice Chancellor, Dayanand Sagar University. I would also like to welcome our beloved principal, Dr. C.P.S. Prakash, Principal, Sir, for the occasion. In the course of the next 3 days, we will interact with seas of expertise in the fields of artificial intelligence, machine learning, data analytics, cyber security, and computational mathematics. Lead kindly light amid the encircling gloom, lead thou me on. In the mark of our undying tradition, to commence our event with the graceful blessings of the Almighty, I invite Professor Suma Manjunath from the Department of Mathematics to present Ganesha Vandana and mark the auspicious beginning of the International Conference ICAAICM 2020.
ಈಗಲೂ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ಅವ್ರಿಗೆ? ಬೇರೆಯವ್ರದ್ದು ಯಾವ್ದೋ ಇರ್ಬೇಕು, ನಂದಲ್ಲ. ಈಗಲೂ ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ಅವ್ರಿಗೆ? ಬೇರೆಯವ್ರದ್ದು ಯಾವ್ದೋ ಇರ್ಬೇಕು, ನಂದಲ್ಲ.
That was indeed a melodious and blissful redemption theme, Suma. Thank you for that. To welcome is to honor. To welcome is to establish integrity. I now invite upon Dr. CPS Prakash, Principal, Danand Sagar College of Engineering, to deliver the welcome address. Team Suma, thank you for that. To welcome is to honor. To welcome is to establish integrity. I now invite upon Dr. CPS Prakash, Principal, Danand Sagar College of Engineering, to deliver the welcome address.
On applications of artificial intelligence and computational mathematics, jointly organized by Department of Computer Science and Engineering, Information Science and Engineering, and MCA department, along with
Team Suma, thank you for that.
We have with us
to welcome is to honor. To welcome is to establish integrity. I now invite upon Dr. CPS Prakash, Principal, Danand Sagar College of Engineering, to deliver the welcome address.
On applications of artificial intelligence and computational mathematics, jointly organized by Department of Computer Science and Engineering, Information Science and Engineering, and MCA department, along with
Team Suma, thank you for that.
We have with us and computational mathematics, College of Engineering, jointly organized by Department of Computer Science and Engineering, Information Science and Engineering, and MCA department, along with
Team Suma, thank you for that.
We have with us good morning. Welcome to each one of you. It gives me immense pleasure to welcome Science and Computational Mathematics, jointly organized by Department of Computer Science and Engineering, Information Science and Engineering, and MCA department, along with
Team Suma, thank you for that.
We have with us and MCA department, along with Department of Mathematics. We have with us Dr. K. N. Balasubramanian Murthy, Vice Chancellor of Sagar University. Welcome to
I'm extremely sorry for the glitches. A moment to get back to you. I'm extremely sorry for this. I'm extremely sorry for the glitches. A moment to get back to you. I'm extremely sorry for that.
Good. Good morning. Welcome to each one of you. It gives me immense pleasure to welcome each one of you for this international conference on
I'm extremely sorry for the glitches.
artificial intelligence and computer.
A moment to get back to you. I'm extremely sorry for that.
Organized by Department of Computer Science and Engineering, Information Science and Engineering. Welcome to each one of you to inaugurate. It gives me immense pleasure to welcome each one of you, all the members of this international conference on
I'm extremely sorry for the glitches.
artificial intelligence and computer.
A moment to get back to you. I'm extremely sorry for that.
Organized by Department of Computer Science and Engineering, Information Science and Engineering. Similarly, we have Dr. Kusum Deep, Professor Mathematics IIT Roorkee, and also visiting professor for Liverpool Hope City. Welcome to each one of you to inaugurate. It gives me immense pleasure to welcome each one of you, all the members of this international conference on
I'm extremely sorry for the glitches.
artificial intelligence and computer.
A moment to get back to you. I'm extremely sorry for that.
Organized by Department of Computer Science and Engineering. It will act as a good value. Good morning. Welcome to each one of you. It gives me immense pleasure to welcome each one of you for this international conference on applications of artificial intelligence and computational mathematics, jointly organized by Department of Computer Science and Engineering, Information Science and Engineering, and MCA department along with Department of Mathematics. We have with us Dr. K.N. Balasubramanya Murthy, Vice Chancellor of Dayanand Sagar University, as the distinguished chief guest to inaugurate the international conference. I, on behalf of all the members of the organizing committee and faculty and staff of Dayanand Sagar College of Engineering, extend a hearty welcome to our beloved Vice Chancellor, Dr. K.N.B. Murthy, sir. Welcome to you, sir. Similarly, we have Dr. Kusum Deep, Professor Mathematics IIT Roorkee, and also visiting professor for Liverpool Hope University, United Kingdom, to deliver the keynote speaker. I extend a hearty welcome to Dr. Kusum Deep on behalf of all the members of the organizing committee. We have with us our beloved Secretary, Sri Gali Swami, who has been the pillar of support for all the activities that we do at DSCE. I, on behalf of all the members of the organizing committee, faculty and staff, extend a hearty welcome to our beloved Secretary. I welcome all the participants for this international conference. I take this opportunity to compliment the organizing committee members of this international conference for their efforts in realizing this international conference into a reality. I am of the strong opinion that this international conference would provide a platform for each one of you to network with fellow researchers, and it will act as a good value add to each one of you. I wish each one of you a happy participation time during this international conference. Thank you.
Thank you, sir. I once again apologize for all the glitches that had happened a little while ago. Sorry, dignitaries, apologies for that. We are now back on track. Everything is fine. So let's please continue with the inauguration event. I now call upon Dr. Amita S., Professor, Department of Computer Science and Engineering, DSCE, to welcome our guest of honor today, Dr. K.N. Balasubramaniamurthy, Vice Chancellor, Dayanand Sagar University, for the occasion. Ma'am, please.
Good morning, all. I, Dr. Amita S., Professor, Computer Science and Engineering Department, Dayanand Sagar College of Engineering. It's our privilege and pride to have Dr. K.N. Balasubramaniamurthy, Vice Chancellor, Dayanand Sagar University, as our chief guest for this conference. I feel happy to give a brief introduction about our esteemed chief guest, Dr. K.N. B. Murthy. He completed his engineering in 1980, followed by his master's in IISc Bangalore and his doctorate from IIT Madras. He comes with a vast experience spread across 35 years. He had been instrumental with his contributions to the academia in multiple organizations. He is also the recipient of CM Nagaraj Memorial Award 2018 for his contributions to the higher education sector. He is also the chairman of BITES. We are extremely honored to have Dr. K.N.B. Murthy as our chief guest, and we cordially request you to deliver the inaugural address. Welcome, sir.
Thank you, ma'am. I now welcome Dr. Murthy for the inaugural address. Sir, please.
Good morning. It gives me immense pleasure to be a part of this 3-day virtual international conference on applications of AI and computational mathematics, organized by the departments of. Good morning. It gives me immense pleasure to be a part of this 3-day virtual international conference on applications of AI and computational mathematics, organized by the departments of Computer Science and Engineering, Information Science and Engineering, MCA, and Mathematics of Dayanand Sagar College of Engineering, Bangalore. This conference is very relevant in the sense the topic chosen has plenty of applications. To tell you few points about AI, application of AI and the computational mathematics. AI has transformed several domains such as web search, e-commerce, logistics, advertising, and finance, and several others. With the early trends and with the kind of initial signals that we have been receiving, it appears AI, or the artificial intelligence, will soon transform the sectors of healthcare, transportation, cybersecurity, and even education. Coming to the computational mathematics, it's a bedrock for the AI algorithms and techniques. It's very clear that computational mathematics has been used in several AI-based applications. For example, computational geometry is being used in protein folding algorithms, which are used for detection of cancer and COVID-19. I'm sure the topics of computational mathematics, such as the linear algebra and optimization, will find several applications in weather forecasting, satellite imagery, and cybersecurity. And it's very clear that AI, the application of AI in computational mathematics, are required in some of the application areas, such as autonomous or self-driving cars, robots for e-commerce delivery, search and rescue robots in the applications of disaster management, human language translation and understanding. Again, AI will be very useful. Internet of Things and its analytics in smart city projects, etc. The AI finds lots of applications. While we are looking at the applications of AI and the computational mathematics, we also need to be very cautious with regard to the side effects or the shortcomings of AI and the computational mathematics, especially when computational mathematics is used in AI. One such application is increasing personalization may overpower privacy. That's one area where we need to be cautious. Second, any simple intelligent algorithm requires vast data. Thereby, the processing time will be that much higher. Therefore, that's one of the shortcomings or the side effect. The third, over-reliance on technology for safety and survival. It also becomes a kind of difficult situation to handle in the long run. Therefore, be necessary for us.
It's like give you everything, whatever you ask.
AI.
Yes. Sir, can I say guy? Yeah.
That missions.
I request all to please mute yourself. I request all to
do not understand.
I request all of you to kindly mute yourselves.
Models. Therefore, when we use AI, that we also need to build some of these components into those AI algorithms. I am sure this several topics pertaining to the application of AI and computational mathematics will be explained and described by experts in the next 3 days, because this conference is held from December 7th to December 9th. I'm sure a lot of topics are going to be discussed. They'll also give you the various inputs pertaining to the topic. Finally, I take this opportunity to thank the organizers of this conference to be a part of this inaugural function and say a few words on the occasion. I wish this conference a great success and the participants would benefit immensely from the deliberations in this conference. Thank you.
The red color markings. First, pass the balance factor value to the leaf nodes 0, 0, 0 straight forward.
I request all the participants to kindly mute yourselves.
One.
I once again request all of you to kindly mute yourselves.
One. Next.
Dr. Tajuddin, kindly mute yourself. Thank you. Thank you. I now call upon Dr. Radha Gupta, Head, Department of Mathematics, DSCE, to talk about the conference as a whole. So kindly, ma'am.
Yeah, I think as a host, you can mute all the other participants. You can make me the co-host and mute all the other participants.
Yeah, I had done that, ma'am, earlier.
Okay.
Yeah.
Okay, thank you. Very good morning to one and all present here. I am Dr. Radha Gupta, one of the conveners of this conference, and I'll be kicking off the 3-day international conference on applications of AI and computational mathematics, which is starting today. It's my pleasure to walk you through the conference, introduce you to the speakers and delegates that have come from all over the globe to share their knowledge and enhance our mental horizon. This conference has about 250 participants participating from India and abroad, making this conference a truly international conference in spirit. This conference holds special value because this is the first conference in the history of our college where the entire conference is taking place on a digital platform. Due to the changing time caused by the COVID-19, we encourage our participants to stay safe and maintain social distancing, as a result of which this conference will be the first of many conferences in the future that will be conducted remotely through the use of advanced technologies and virtual reality. The theme of this international conference, Applications of Artificial Intelligence and Computational Mathematics, aspires to provide an opportunity for the delegates and participants to share and contribute their original research experiences in the field of artificial intelligence, machine learning, cybersecurity, and computational mathematics application areas. Artificial intelligence and computational mathematics are two branches of the same tree. Computational mathematics involves mathematical research in maths as well as in the areas of science where computing plays a central and essential role and emphasizes algorithms, numerical methods, and symbolic computations. The idea behind thinking machines and the possibility to mimic human behavior is done with the help of mathematical tools like rules, frames, logics, and nets. The primary purpose of AI is to create acceptable models for human understanding, which can be prepared with the idea and strategies from various branches of mathematics like linear algebra, calculus, probability, numerical analysis, and optimization. We have experts from across the globe who will be staying with us for the next 3 days, sharing their thoughts, knowledge, and opinions with the rest of us. The conference committee have carefully selected the theme for this conference with an opening keynote presentation by Dr. Kusumdeep, Professor IIT Roorkee, followed by other presentations and plenary sessions by eminent speakers providing the views of industry, government, and academia. And finally, we have 14 dedicated chaired paper sessions. Today, our second speaker would be Mr. Syed Raza Ali Qadri, Engineering Manager from Cisco Systems, followed by a talk by Dr. Ram Ramanathan, Professor Operations Management and Director of BMRI, University of Bedfordshire, UK. Day 2, we will be listening to some of the expert talks by Ms. Nimita Sharath Sharma, Data and Applied Scientist, Microsoft, Seattle, USA, Dr. M. Mathirajan, Professor of Management Studies, IISc Bangalore, and Mr. Victor Sundaraj, Head Engineering Academy, Infosys, Bangalore. Third and concluding day, we will have the pleasure of listening to Dr. Krishna Chandra Gowda, Senior Scientist from CSIR, Bangalore, Ms. Vandana Verma, Solution Security Architect, IBM, India, and Mr. P.G. Bhatt, Founder and Director, Pluma Knowledge Solutions, Bangalore. We have received a total of 130 papers in 4 different tracks: AI and ML, cyber security, computational mathematics, and data analytics, of which 116 have been accepted for oral presentation. Peer-reviewed selected papers will go for publication in Scopus Index Journal, which we are going to notify shortly. The major outcomes that we expect from this conference is a national and international framework for the changing dynamics around the world during COVID-19 pandemic and how applications of AI can come to the rescue of human beings. The conference will showcase research undertaken by undergraduate, postgraduate students, and experienced researchers on the various topics related to applications of AI and computational mathematics. I would like to conclude this introduction about the conference by encouraging the delegates to participate with an increasing number in all the activities and discussions through the digital platform for the next 3 days. I wish everyone a successful, safe, and fruitful conference. Thank you.
Thank you, Radha ma'am. I now call upon Sri Galiswamy Sir, Secretary, Dayanand Sagar Institutions, to give the presidential address. Sir.
To preside over the inaugural program. Good morning. Welcome to the Dayanand Sagar College of Engineering. It gives me immense pleasure to preside over the inaugural program of international conference organized by the Department of Dayanand Sagar College of Engineering. In this critical juncture of COVID-19 pandemic, it becomes essential for each one of us to take care of ourselves and the surroundings, make best use of technology, and ensure that the academic practices continue for the benefit of the society. I hope the international conference would provide an opportunity to the research scholars to present their work and to interact with fellow researchers through strong networking, opportunity developed through the international conference. I wish all the participants of the international conference a happy interaction and compliment all of our faculty coordinators, HODs of the departments, and the principal for organizing this international conference. Thank you.
Thank you for your kind words, sir. Today on day one of the conference, we have in the technical sessions, as mentioned by Dr. Radha Gupta, keynote talk by Dr. Kusumdeep, and that will be followed by 2 plenary sessions. We now call upon Dr. Samita Khayyum, Head MCA DSCE, to give a formal closure to this inauguration event by presenting the vote of thanks. Today's keynote session will immediately commence after that. I request all the participants to kindly be present for all the sessions, because we have planned all these sessions with the intent of active and interactive learning. So over to you, Samita ma'am.
Thank you, Vindhya. It's a pleasure to deliver the vote of thanks for the event today. First and foremost, I would like to sincerely thank the management of Dayanand Sagar College of Engineering, who has given us this opportunity to host the International Conference on Applications of AI and Computational Mathematics 2020. They have been a constant support to us. A deep appreciation and gratitude to our Secretary Shri Grali Swami and our Principal Dr. CPS Prakash. Their motivation and constant encouragement has made this event possible. Heartfelt gratitude to our distinguished chief guest, Dr. K.N. Balasubramaniam Murthy, Vice Chancellor DSU, for gracing the occasion. This event is a joint venture with collaborative efforts from the Departments of Computer Science and Engineering, Information Science and Engineering, MCA, and Mathematics. I hereby take this opportunity to thank the heads of the departments, coordinators of various committees, faculty and staff of all these participating departments. Their dedication and sincere effort has made this possible. I now take this opportunity to thank the keynote speaker, Dr. Kusumdeep, plenary speakers for the next 3 days, and the delegates for their enthusiastic participation in the conference. I'm also thankful to our students and research scholars who have greatly helped us in organizing this conference. I sincerely thank our associating partners, Operational Research Society of India, Bangalore Chapter, Soft Computing Research Society, Computer Society of India, Bangalore Chapter, for their generous support. I thank each one of you for gracing this event today. I once again thank everyone whose contribution has made this a successful conference. Thank you again.
Thank you, Samita ma'am. Moving forward, let's begin with the technical sessions for the day. We first have with us Dr. Kusumdeep, Professor, IIT Roorkee. I call upon Dr. Radha Gupta, Head Mathematics DSE, to introduce the speaker. Ma'am, over to you again.
Yeah, thank you, Vindhya. It's my privilege to introduce today's keynote speaker, Dr. Kusumdeep. Dr. Kusumdeep is a professor with the Department of Mathematics, Indian Institute of Technology, Roorkee, India, and visiting professor, Liverpool Hope University, UK, and University of Technology, Sydney, Australia. She pursued BSc Honours and MSc Honours School from Centre for Advanced Studies, Punjab University, Chandigarh. An MPhil gold medalist, she earned her PhD from Indian Institute of Technology, Roorkee in 1988. Her education has been assisted by UGC National Scholarship. She carried out postdoctoral research at Loughborough University, UK during 1993-94 under an international postdoctorate bursary funded by Commission of European Communities, Brussels. She was awarded the Khosla Research Award in 1991, UGC Career Award in 2002, Star Performer of IIT Roorkee faculty continuously from 2001 to 2005. She was awarded Best Paper Award, Railway Bulletin of India Railways 2005, Special Facilitation in Memory of Late Professor M.C. Puri in 2007, Outstanding Paper Award during 2nd International Conference on Harmony Search Algorithm, Korea University, Seoul, South Korea in 2015. Best Paper Award during International Conference on Operations Research and Decision Sciences, IIM Vishakhapatnam in December 2019. And AIAP Excellence Award in December 2018. Professor Kusumdeep has co-authored a book entitled Optimization Techniques by New Age Publishers, New Delhi in 2009, with an international edition by New Age Science UK and a second book on nature-inspired optimization and introduction by McGraw-Hill. She has supervised 20 PhDs and published 125 research papers. She has conducted numerous research and consultancy projects. She is a member of IEEE, ORSI, CSI, IMS, and ISIM. She is the executive editor of International Journal of Swarm Intelligence in the Science and is associate editor of Swarm and Evolutionary Algorithms Elsevier. She is on the editorial board of many journals. She is also the founder president of Soft Computing Research Society India, with which we are partnering in this conference. She is the general chair of series of International Conference on Soft Computing for Problem Solving. She is the series editor of Algorithms for Intelligent Systems Springer. Her research interests are evolutionary algorithms, swarm intelligence, and nature-inspired optimization techniques and their applications. Ma'am, it's our privilege and honor to have you as our keynote speaker for the first international conference on applications of AI and computational mathematics in virtual mode. We welcome you wholeheartedly for this conference. Welcome, ma'am. Thank you.
Thank you so much, Dr. Radha, for your kind introduction and your very sweet words. First of all, let me extend a warm welcome and a very good morning to all of you who are present here. I would like to thank Dayanand Sagar College, the management committee, the principal, the staff, and everybody who is behind this international conference, and also to give me this opportunity to present my talk before the audience. I can see that there are a good number of participants in this international conference from all over the world, which is really very, very encouraging to see. So this conference on International Conference on Artificial Intelligence and Computational Mathematics is the need of the hour. And if you look at the keywords in the title, the first one is artificial intelligence, and the second one is computational mathematics. So I believe, as the chief guest mentioned, that these are the key words of the future, and no one will be left out from this. So I believe that the organization of this conference is very, very timely, and I hope that all the participants benefit from this conference. My area of research is optimization techniques, and I will be talking about the optimization techniques with an objective to tell you how it can be used in various techniques and tools related to artificial intelligence, because I feel that optimization is one of the pillars of AI. So let's now begin. I'll share my screen. Can you see my screen, Dr. Radha?
We can see, madam. You can make it full screen, yes.
Is it now visible?
Yeah, it's visible. It's visible, but it's, yeah, fine. This is fine.
Right. Okay. So here we go. As I said, I'll be talking about optimization techniques, and particularly I'll be talking about nature-inspired optimization techniques. And I will be touching upon why we need to go into nature-inspired optimization techniques. So this is the flow of my presentation. First of all, I'll tell you what they are, the nature-inspired optimization techniques. And then I will be telling you some success stories. And then I will define a general template for the nature-inspired optimization techniques. With the help of a working example, I will be illustrating three commonly used nature-inspired optimization techniques, and then emphasize their application in real-life problems. And towards the end, I will discuss some of the challenging open problems in this research area. And then I will focus on my research work at IIT Roorkee. So I hope to finish my presentation well in time. Dr. Radha, how much time do I have?
Madam, by another, I think 50 minutes we have, madam.
Okay, great. So thank you so much. So I'll try to finish it within the specified time.
Yeah.
So you can look at my details on the internet to know more about my work, and I would welcome to entertain any query or question either during the lecture or later on. Now, first thing is, what is the meaning of optimization? So as you all know that we encounter optimization in our daily life in some way or the other, which means that starting from choosing any particular option depending upon our requirement, suppose there are a number of alternative options in front of us, and we have to choose the best one. So this is nothing but a simple example of an optimization problem. For example, in this case, we have a hill, and these two people have to climb the hill, and they are looking for a strategy how to climb the hill. So depending upon the priority of the user, whether he wants to spend as less time as possible or whether he wants to spend as little money as possible to climb the hill, he will try to detect the best strategy amongst the various options that are available. So in other words, that we can define optimization to be the best strategy amongst the various alternative strategies. And usually I tell my students as well that I believe that any design problem is ultimately a optimization problem. Because whenever you are designing anything, whether it is a machine, whether it is a road, or whether it is a structure of a building, or whether it is some kind of a network, so any design is actually a optimization problem, because there you are supposed to keep the design in such a way that it is efficient. Now, this efficiency could be in terms of performance, in terms of cost, and you name it. So at the end of the day, I would say that all design problems are optimization problems. Also, whenever you are setting up a situation, for example, a factory, you want to set up a factory, a production factory, you want that the cost should be minimized. And similarly, whenever you want to, let us say, design a building, you want that the cost should be minimized. So cost minimization is a very, very common kind of a problem that we encounter, which actually turns out to be an optimization problem. Reliability is one of the important aspects, whether you are designing a bridge, you are designing a dam, or you are designing equipment. So obviously one is interested in a design where the reliability is maximized. Then comes the least square estimators. That is, whenever there is an experimental data which has to be fit into the forward problem. So you can model the problem as an inverse problem where the least sum of square estimators have to be determined. That is the least sum of squares between the observed and the calculated information. You must have heard about the neural nets, and you know that the performance of a neural net depends upon the weights of the neural net. So these are some of the examples that we come across in scientific endeavor, which depict the optimization problems in video.
Scientific endeavor.
Sorry. Hello. Coming to machine learning. Now, machine learning, as you know, is a very important tool, particularly in AI, which is the title of our conference. So I believe that machine learning needs a lot of applications of optimization techniques, particularly in the sense of classification problems, feature selection, regression analysis, topology optimization, and training the neural nets by optimizing the weights of the neural nets. So with reference to the topic of the conference, I believe that optimization plays a very important role. Why are nature-inspired algorithms preferred over the traditional algorithms needs to be understood, because the traditional optimization algorithms which are available in literature can be applied only to differentiable functions, particularly when you are applying the Tucker theory or the Lagrange multiplier theory. However, the nature-inspired optimization techniques allows you to apply these techniques to those problems where the objective function need not be differentiable. And in fact, it can also be applicable to discontinuous functions as well. Similarly, those objective functions which are non-separable and those functions which are multiplied by a rotational metrics, and of course the ill-conditioned problems, and particularly the NP-hard problems, the curse of dimensionality, these kind of situations where the traditional theoretical algorithms cannot be applied, and this is the place where nature-inspired optimization techniques come into rescue. Keeping in view the characteristics of the real-world optimization problems, as you know that in general, it may be possible that the objective function is non-differentiable, and similarly the constraints, and the constraints could be linear and non-linear, and the search space could be discontinuous, it could be discrete, and the variables could be of different types. For example, they could be discrete, continuous, or permutation. Also, as I mentioned earlier, the large dimension of the problem is very difficult to handle, and the nature-inspired techniques can take care of these characteristics of the real-world problems. And finally, the real-world problems are in general multi-objective in nature, which means that there are two or more than two objectives which are conflicting in nature, but they are subject to certain set of common constraints. And therefore, one has to keep into mind these characteristics of the real world problems. And based on this, the optimization problems can be classified depending upon the following: as the number of decision variables, the type of variables, the degree of nonlinearity of the objective function, the presence of constraints, the number of optima, whether it's a unimodal or a multimodal problem, and the number of optimization criteria, and whether the objective function changes over time. Let me just give you an example about the objective function which changes over time. For example, the forecasting problems, let's say in the forecasting of data, when you're talking about data from the Sensex, the financial data. So now this is a highly dynamic objective function, and one for doing the predictions, one has to design an objective function which is dynamic in nature, and therefore one can talk about these kind of classifications where the problems of optimization can be modeled into different categories. Accordingly, there are unconstrained methods, constrained methods, multi-objective methods, multi-solution methods, and dynamic methods. So I won't like to go into the details, and quickly I'll define, mathematically speaking, what exactly do we mean by a non-linear optimization problem. In general, we are concerned with an n-dimensional problem, which means that we have a real valued function defined over a subset of the n-dimensional Euclidean space, which is actually a real valued function, and the decision parameters x1, x2, xn are n in number, where in general n could be greater than or equal to 1. And the set S is the set of all solutions capital X, which satisfy the following conditions. That is, they have a set of m number of inequality constraints in the form of g1x greater than or equal to 0, etc. And let us say L number of equality constraints, that is hjx is equal to 0. And apart from this, there could be an n-dimensional box of lower and upper bounds on the decision parameters. So we are interested in determining the optimal solutions of this optimization problem. Now let D be the set of feasible solutions of X satisfying all the constraints. Then we can say that X bar belonging to D is said to be a local minima if there exists n epsilon x bar around x bar such that fx is greater than or equal to fx bar for each x belonging to D intersection n epsilon x bar. This is called as a local minima. On the other hand, if this condition f of x is greater than or equal to fx bar is satisfied for all x belonging to the search space, then x bar is called as a global minima. This diagram tries to illustrate what exactly do we mean by local and global minimas. As you can see that there are a number of local minimas which are closely placed amongst each other. This is also a local minima. However, this one is the global because it's the best amongst all the locals. Apart from this, there is a complexity about the stationary point, which actually means that the necessary conditions of optimality are satisfied, but the sufficient conditions are not. This is a pictorial representation to illustrate what do we mean by local and global solutions, where you can see that there are a number of heaps and valleys to illustrate the local and the global optimum solutions. The theory of benchmark functions is very, very rich. For example, the famous ICAAICM problem is an n-dimensional problem where n is greater than or equal to 2, and it's a positive integer, n is greater than or equal to 2, and the objective function looks like this. Since n is a positive integer which can be controlled at will, as and how the value of n is increased, the complexity of the problem also increases. However, for n is equal to 2, this is what the surface of the objective function looks like. That is x1 versus x2 and the objective function plotted on the vertical axis. So you can see the complexity of the problem and how many local minimas are there. In fact, they are not known. However, the global minima is at the origin. Another kind of a scalable problem. These problems are called scalable because their dimension can be controlled, and as and how their dimension is controlled, their complexity also increases. Similarly, another problem which is a scalable problem called the restringent problem, and the Rosen-Proc problem has a different kind of a complexity, which means it is a unimodal problem and it consists of a saddle point. And finally, the last function, which is called the shuffle function, is also very difficult to optimize for any numerical technique. Look at the sinusoidal term with an absolute value under the root. All right. Similarly, there are other objective functions which people have designed, which show the various challenges that are there inherent into the optimization problems. And therefore, we need to design efficient and reliable optimization techniques with a view to solve real life problems arising in different areas of research, that is computer science, biology, physics, engineering, etc. So therefore, one has to think of the developmental design just as you design a building, and look at the evolutionary design, how you would evolutionize it by process. And finally, you come up with the final emergent design of an optimization problem. And the objective is that when you design an optimization problem, it should be as robust as possible, and it should be able to solve as many problems as possible under the sky. Now, the deterministic approach and the probabilistic approach are two numerical approaches which are available in literature. I'm talking about the numerical techniques, not the analytical ones. The deterministic approach methods are those methods in which there is a set transition rule and they move from point to point. For example, the steepest descent method, etc. However, the probabilistic methods are a new category of algorithms, particularly genetic algorithm, memetic algorithm, etc. And in order to understand the difference between the two approaches, let us look at the scenario where the deterministic approach is a point-to-point method. It does not have any probabilistic factor into its formulae. The probabilistic approach has a random number, and it involves more parameters into it, so that when the convergence takes place, they converge in the limiting sense. Now, what is the definition of nature-inspired optimization techniques? The nature-inspired optimization techniques are those techniques which derive their inspiration from some natural phenomena existing in nature, whether it is the way in which the humans or the living creatures they behave, or whether it is some other natural phenomena, for example, gravity. This is a list, I would say a partial list of some of the nature-inspired optimization techniques. And here is a classification. They are also called meta-heuristic algorithms. And you must have heard about the evolutionary algorithms and the swarm intelligence-based algorithms. So the traditional algorithms, the difference between the two is that the nature-inspired techniques, they search from a population of a solution rather than a single solution. As I mentioned, for example, the Newton-Raphson method or the steepest descent method, it starts from an initial guess, let's say X naught. And this initial guess keeps on updating itself over and over the iterations till the convergence is attained and the minima is also attained. These are the deterministic methods which I was talking about. On the other hand, we have the probabilistic methods where the same minimization process will be done in a different fashion. And the method is that instead of one solution, 3 solutions have been generated randomly in the search space, and the objective function is evaluated at each of them in such a way that at the next iteration, these 3 solutions will be updated. So here you can see that the solutions have been updated. Now, this process of updating the solutions based on various operators and various criteria is the backbone or the template of any nature-inspired optimization technique. In order to understand this concept, let us look at a 2-variable problem. So suppose you have a X versus Y scenario, and this is the feasible region, and there are, let us say, 10 randomly generated feasible solutions, and the minima is, let us suppose, over here at the red dot. Now, according to the nature-inspired technique, the operators that you use, you keep on updating the generation or iteration, usually it is called as a generation, you find that all these solutions, they keep on converging closer and closer to each other. And finally, when the convergence occurs, then they cluster to the global minima. The second difference between the nature-inspired techniques and the traditional algorithms is that they use probabilistic transition rules instead of the deterministic rules, which means that in the formula, there are some kind of random numbers inherent into it. And a very important point is that the nature-inspired algorithms can be applied to discontinuous functions as well as non-differentiable functions, and they are very simple to program and have a wide applicability. Now, coming to the classification of the nature-inspired techniques, I usually classify them into 4 categories. The first is the evolutionary algorithms. Second is the swarm intelligence-based algorithms. Third is the algorithms based on physical laws. And fourth is the miscellaneous category. Now, the evolutionary algorithms are those algorithms which derive their inspiration from the Darwin's theory of evolution. There are many methods in the category of evolutionary algorithms. For example, the genetic algorithms, differential evolutions, evolutionary strategies, and genetic programming. The Darwin's theory of evolution was proposed by a famous scientist, Darwin, which has 2 basic properties. The first property is the property of inheritance, which means that the good traits of the current generation will be passed on to the next generation. For example, in human beings, we want that the properties of intelligence and beauty, etc., should be passed on to our children. In the scenario of algorithm, we will randomly generate feasible solutions and look at their performance in terms of the objective function. If those solutions are having good fitness or good objective function value, then they will be carried over to the next generation. Otherwise, they will die. Second property is the property of competition or the survival of the fittest, which means that a criteria called the fitness criteria is used to compare 2 and more than 2 randomly generated feasible solution at the kth iteration, and the one which is more fit will survive and the rest of them will die. Now, coming to the success stories, the way in which the nose of a high-speed bullet train is designed is a highly complex problem, as you can understand. It has a number of parameters, and according to one of the famous Japanese website, genetic algorithms was used to design not only the airplane wings, but also the design of a nose of a bullet train. Second category is the category of swarm intelligence-based algorithms, which derive their inspiration from the way in which birds fly in the sky and the fish, they swim in the pond. Some of the methods in this category are the particle swarm optimization, the gray wolf optimization, artificial bee colony algorithm, the spider monkey algorithm, Harris hawk, and there is a whole list of them. The third category is the category based on physical laws, particularly the law of gravity and the law of central force. Of course, I cannot touch upon each of them in this particular lecture. The fourth category is the miscellaneous one, where harmony search is an algorithm which is based on composition of music, and similarly, biogeography-based optimization is based on the way in which emigration and immigration takes place. And like that, the sine-cosine algorithm and the tug-of-war, water drop, teaching learning-based algorithms, and a lot many more. Now, coming to the historical development of these nature-inspired techniques, first of all, was the most commonly used one was the Monte Carlo simulation. Then came the random search, and the property of the random search algorithm was that it had 2 phases. In the first phase, the objective function was evaluated at a number of randomly generated feasible solutions. And during the second phase, these solutions were manipulated to obtain a better candidate for the global minima. And this process was repeated until the stopping criteria was satisfied. You must have heard about the way ant colony algorithm works. This is the way in which the ants, they follow each other in a path like this. Now, what is their inspiration of following this path is dependent upon a scent, which is called as pheromone. And this pheromone, the trail of this pheromone helps the follower to follow the one it is behind. The property of these ants is that as and how any obstacle comes into their way, they change their path, and that path is usually the shortest path. Based on this movement of the ants, the ant colony algorithm has been proved to be very, very successful in solving many discrete optimization problems. Genetic algorithms, as I mentioned, is one of the very popular and one of the oldest nature-inspired technique. It was developed by Holland in 1975, and later on, many other workers have worked in this direction. The genetic algorithm, as I said, mimics the way in which life has occurred. As you know, that in the beginning, there was a one single cell amoeba, and that cell amoeba became more and more complicated till we all became human beings, and tomorrow we might become superhuman beings. Now, the one cycle of a genetic algorithm looks like this. That is, we initialize the population with randomly generated feasible solutions and evaluate them using some fitness criteria. From this population of solution, a subset is chosen based on the fitness. So the best fit ones are selected as parents. And from these parents, a breeding process is carried out, which is called as the crossover operator, and the children are obtained. From this children, the mutation is performed, which is a small change in one of the genes or the characters. Like this, one particular cycle of a genetic algorithm is completed. Repeatedly, this chart illustrates how such a typical cycle is repeated over and over again, so that when the convergence occurs, we reach the global solution. So natural selection is the basis behind genetic algorithms, and it has been shown that GAs are adaptive and they learn from their experience, which means that given your problem at hand, you can design your own GA the way you like, depending upon various conditions that are available. And they have been shown to perform very, very well over highly complicated problems. The basic operators of a genetic algorithm are encoding, selection, crossover, mutation, and elitism, where encoding is a one-time operator, whereas the remaining ones are repeatedly applied. For example, the tournament selection is one of the popular selection operators which give preference to those individuals which have a higher fitness. So for example, you can see that here we have 8 individuals, and a tournament is being played between each of the pairs, and the better one is put in the mating pool. Similarly, the roulette wheel selection is a selection operator which is giving the proportion. It is a proportionate operator depending upon the proportion of the fitness of the entire group of feasible solutions. Then comes the crossover operator, which actually depends upon the way in which the encoding has been performed. And depending upon the encoding, if it's a binary encoding, then the crossovers are many types of crossovers are available. Similarly, for a real encoding, again, many types of crossovers are available. And similarly, the mutation operators are also dependent upon the way in which the encoding has occurred. In general, the pseudocode of a GA looks like this. That is, you generate an initial population, and till the stopping criteria is not satisfied, evaluate these individuals and apply the various genetic algorithm operators. Then came the real coded genetic algorithm operators, and my research work focuses on the design of new real coded genetic algorithm crossover operator and real coded mutation operator. Then in 1992, memetic algorithms were introduced, which are nothing but hybridized genetic algorithms, which incorporates some kind of a local search into them. The objective is to improve the performance of genetic algorithm. Now, this local search is incorporated at many situations, either at the initial phase or within the main loop of the GA. Self-organizing migrating genetic algorithms were proposed, which derive their inspiration from self-organizing patterns appearing in nature. Now, swarm intelligence are the most recent algorithms which mimic the behavior of a group of birds flying in the sky. I'll play a small video to illustrate what is the meaning of swarm behavior. You will see that here, a tree, on this tree, there are a number of birds which are sitting. And as in now, how I start this video, you will find that all the birds, they start flying in different directions. And very soon, you will find that they realize that instead of flying from different directions, now we should actually follow the birds which are going towards the right direction. So just I'm playing this video. Please observe it carefully, and you will understand what is the meaning of swarm behavior. Something has gone the wrong with this. Sorry about that. It's not working. Okay. Then comes the success stories of the swarm behavior. You must have observed and heard about drones. Now, drones, they play a very important role, not only in defense, but also in civilian problems, for example, flood hit areas, etc. So the swarm drones are those drones which derive their inspiration from swarm intelligence behavior. So they are mimicking the behavior of birds, and they, without any human intervention, they actually perform the determination of the target. Now, coming to the better understanding of these concepts, let us take a simple example of a function which is to be minimized, a function of n variables, which is to be minimized between the lower and the upper bounds. And as an example, suppose I'm taking x1 squared plus x2 squared with different bounds on the lower and upper bounds on x1 and x2. Now, the general template of a nature-inspired techniques looks like that we initialize the population size and the maximum allowed iterations and generate a population of randomly generated feasible solutions in the search space and evaluate the objective function at each of them, and then initialize the iteration and perform a bigger loop for iteration equal to 1 to maximum iteration allowed, perform the operators based on the nature-inspired optimization technique that you're using, and repeat till the optimum solution is obtained. Now, this template is a generalized template for any nature-inspired optimization technique. The first step is how to generate an initial population. Now, this is usually done randomly with the help of a uniformly distributed random number generator, depending upon the platform that you're using. So you generate a random number, let's say small r, between 0 and 1, and then scale it between the lower and the upper bound of the given problem. You can use this simple linear transformation to get a new number, capital R, between x min and x max. So for example, if you generate R is equal to 0.16345, then you can get capital R using this linear transformation like this, and similarly for the other dimension. So in other words, the first randomly generated feasible solution could be something like this. This process has to be repeated for the entire population of your problem. Next step is the evaluation of the objective function. So all you need to do is put this value into your objective function, and this is what you get. Repeat this process for all the feasible solutions of the population, and you can keep a record of the best and the worst feasible solutions in the population. Now comes the application of the various operators that you are planning to apply. whether it is a GA, whether it is a PSO, or whether it is an ABC. Coming to when to stop. Now, there are a number of ways in which you can stop the algorithm. The first and the most commonly used one is the maximum number of predefined iterations by the user. Also, you could use another stopping criteria, which means that the objective function value between the worst and the best is within an epsilon limit at any iteration. And another way could be that you look at the best solution at the iteration number k and iteration number k minus 1. And the moment it is less than epsilon, you can stop. Also, you could use any combination of any of these stopping criteria, and you could make your nature-inspired optimization technique stop. Now, I'm going to take three algorithms, the PSO, the Grey Wolf, and the ABC algorithm. The choice of these three algorithms is purely random, and there is no bias against each of them. Now, in order to understand PSO, we initialize instead of the population, we call it as a swarm, and we evaluate the fitness of each of these particles in the swarm, and then modify their global best position, their personal best position, and their velocity, and move each particle to a new position and repeat this process. This is the simple flow chart of a PSO algorithm. These are the two governing equations. The first equation is called the velocity update equation, which means that the velocity of each particle is updated based on the velocity of the particle at its previous position, and also the position of the global best, which means the best position of the entire swarm, and the personal best means the best position of each particle over history. Also, the second equation is called the position update equation, which is current is equal to current plus V, which means that these two governing equations gives rise to the particle swarm optimization. Now, suppose, coming back to the same problem, which I was trying to solve, x1 squared plus x2 squared, we know that the solution is at the origin, but let's see how our PSO is going to work. So suppose I take a population of 6 solutions randomly generated. Of course, they could be real numbers, but for the sake of simplicity, I'm taking them as integers. And then I evaluate the objective function at each of them. I find that the third one is the best. Now I'm going to apply the two governing equations, that is the velocity update equation and the position update equation. And I find for the first particle, this is what I get. And similarly for the second particle and the third particle. So now the updated swarm looks like this. And what I find is that now the best solution is having an objective function value 1.37. So starting from objective function value 2, I have reached at 1.37 in just one iteration. If this process is repeatedly applied, I can keep on improving the best solution like this. The second algorithm I'm going to talk about is the Grey Wolf algorithm, which is an algorithm which mimics the hierarchical behavior of gray wolves, that is, who live in a pack. And the best wolf is said to be the alpha wolf. The second best is called the beta, and the third best is called as delta wolf. And the remaining ones are called as omega wolves. These are the governing equations, and the objective of the gray wolves is to encircle their prey and then catch it and then attack it. So the hunting mechanism is modeled using these equations, and then the attacking is done using this averaging principle. This is the pseudocode of a Grey Wolf optimization algorithm. Coming back to the same example, the gray wolves are numbered like this. This is the initial population. Same data I have taken to illustrate the comparison between each of them. And what I find is that this one is the omega wolf, the alpha wolf. And as and how I apply the first iteration, I find that the first updated wolf looks like this. And similarly, the other wolves in the pack, that is second, third, fourth, fifth, sixth, they are obtained like this, which means that after the first iteration, the fifth wolf is now the best wolf. So it is giving me a value of 0.012. Then I apply the second iteration, and I find that I need to apply the greedy selection, and therefore now the alpha wolf is 0.012, which means that the second iteration didn't really help. So we go back to the first iteration itself and now apply the third iteration. The third algorithm that I'm going to talk about is the ABC algorithm, which was developed by Karaboga in the year 2005. And it mimics the self-organization and division of labor property of the honeybees in the swarm. Now, there are three components, the food sources, the employed foragers, and the unemployed foragers. Foragers are those particles who are actually looking for food, and food source is the most important component of a honeybee. So the types of foragers are divided, which is based on the property of self-organization. And each of these bees, they perform a dance to tell the others where the food is available. The artificial bee algorithm has been designed using this principle of the bees. And we find that there are three types of bees: the employed bees, the onlookers, and the scouts. The purpose of each of these bees is different and outlined here. This is the social behavior of the honeybees. And as I said, the distribution of bees is performed over all the search region. Let us now come back to our original problem. And we find that if we generate 6 randomly generated bees, the third one is the best as before. And we now apply the principles of the ABC algorithm. And what we find is that when we apply the principle of the employed bees phase and the onlooker bee phase, then after the first iteration, this is what we get. I'll quickly move on to this is the first phase, first cycle. So the objective function value is now 0.0362. And like this, after cycle number 2, I get 0.0362. So with this, now we are ready to analyze what happens to the best solution during the initial and the first and the second iteration of the 3 algorithms that we worked on, the ABC, Grey Wolf, and PSO. And we find that in the initial stage, the best solution was having a fitness of 2. Purposely, we had taken the same fitness just to make sure that we are not biased towards any of them. Similar performance can be analyzed with the help of the worst solution, and we find this is the behavior of the 3 algorithms. But this is not all. We would also be interested in looking at the entire behavior of the entire group. So we find that at the 0th iteration, all the 6 population members were looking like this, and this is what happened at the first and the second iteration. Now the question is that would come to your mind is, after all, the best? Now the answer to this question lies in the no free lunch theorem, which says that there is no particular single meta-heuristic algorithm which is best suited to all optimization problems of varied complexities. Now this means that depending upon the various kinds of complexities in the various kinds of optimization problems which exist, you cannot design one single algorithm which is going to solve all kinds of problems. This concept can be understood with the help of a simple example that you cannot have one medicine for all diseases. For example, if you have a blood pressure, you have to take a different kind of a medicine. If you have a diabetic problem, then you'll have to take a different kind of a medicine. So like this, the no free lunch theorem given by Walpred and McCarty in the year 1997 is a strong basis for more and more research in this research area. So coming to the open problems in this research area, the first open problem is how to analyze these nature-inspired optimization techniques mathematically in terms of their convergence, their stability, and their robustness. Still, a lot of scope of research is available in this concept. And similarly, the second problem, which is the fine-tuning of the parameters for any given algorithm so as to achieve its best performance. As you know, all the nature-inspired optimization techniques are based on a number of parameters, and it is important that we need to design some kind of a strategy by which we can fine-tune these parameters. The third problem is to design new types of benchmarking problems. As I had shown, that there are a number of benchmark problems. Still, there is a lot of scope of research how you can design new and new optimization problems. The fourth problem is to identify the most suitable performance matrices for a fair comparison of these nature-inspired optimization techniques. And finally, the fifth one, how to scale up the algorithms which work for small-scale problems, but they should be able to solve large-scale problems more efficiently. Coming to the end of my talk, the research work done by my students on genetic algorithms are shown here. Similarly, the particle swarm optimization, and then later on, particularly I would like to highlight artificial bee colony. This was designed by one of my students, Dr. Amrik Singh, where we used the ABC algorithm for forecasting of avalanches in DRDO, SASE, Chandigarh. And these are my current students who are working in different areas. These are some of the books if you're interested in nature-inspired optimization techniques. My book is in press, and this is a very good friend of mine, Xinxi Yang. You can get hold of his e-book as well. If you're interested to publish your work, you can look at these journals. Of course, the internet does these tricks. And finally, some announcements. I'm the president of the Soft Computing Research Society and the executive editor of the International Journal of Swarm Intelligence. And I'm also the general chair of the SOC-Pro series of conferences, which is going to be held at IIT Indore. And finally, I'm the series editor of Algorithms of Intelligent Systems. So if you'd like to submit a proposal, you're welcome. Thank you so much for being a lovely audience. Any questions, I'll be very happy to answer.
Thank you, Dr. Kusumdeep. That was indeed a very good insight to the trends and techniques in optimization technique. And I'm sure that the participants, particularly the research research scholars here, have enough points to ponder on after the talk. Audience, you are now open to questions. If any queries, you can either type in the chat box so that I can read it, or you can ask yourself. Anyone from the audience, please?
One of the research scholar is asking, thanks a lot, ma'am. Will the PPT be shared?
Oh, that's absolutely not an issue. I'll just share it off right away. It's a pleasure. Sure.
Vishal Patil is asking whether he can ask a question. Madam, can you unmute him?
Of course.
Vishal Patil?
Yes. I think he's now unmuted. You can go ahead, Mr. Vishal.
Yes, Vishal, you can ask.
Yes, please.
Hello.
Yes, we can hear you. Please go ahead.
Good morning, Kusumdeep ma'am. It was a great pleasure listening to you.
Thank you so much.
Yeah, I am a student of Dr. Radha Gupta, and we are working on least cost feed formulation for livestock animals. We are using stochastic and non-stochastic models actually. I have a question for you, ma'am.
Yes.
Can we use this graph theory to convert LPP models? And if we convert, is it feasible to solve using a graph theory like minimum flow model and maximum flow models?
I don't know whether I'm competent enough to reply to your question because I really don't know what your problem is. But definitely we can have a look at it. You can talk to me later on, and I can first look at your problem and then suggest what exactly is your problem. If it is a network optimization problem, then definitely you can use graph theory. Why not? But as I said, without looking at the problem, I cannot suggest any suggestions.
Yeah. Okay. Thank you very much, ma'am. I will get back to you, ma'am.
Please do. Yeah, sure. Thank you so much. Yeah.
Thank you, Mr. Vishal. Thank you once again, Dr. Kusumdeep, for your talk on optimization techniques. Thanks a lot.
Thank you so much. My pleasure.
Thank you so much, ma'am.
Thank you. Thank you so much. Thank you.
Let's move on to the first plenary talk today. We have with us Mr. Syed Raza Ali Qadri from Cisco Systems to give us a talk on cybersecurity in the mobile world. Sir, I request Dr. Radha Gupta to introduce the speaker, please.
Yes, thank you, madam. It's my pleasure and honor to introduce today's first plenary speaker, Mr. Syed Raza Ali Qadri. Mr. Syed Raza Ali Qadri is currently working as the engineering manager in Unified Communications domain at Cisco Systems, Bangalore, for past 10 years. He completed his Bachelor of Engineering in Computer Science and Engineering and holds a master's degree in software system from BITS Pilani. With an overall experience of more than 15 years in the field of collaboration technologies, networking, EMS and NMS domains, and cloud applications, Mr. Syed Raza Ali has been leading software development teams and vendor management at Cisco Systems. Mr. Qadri has an extensive experience working on agile projects using Scrum approach, RESTful web service development and maintenance, develops model of service support, to name a few. His expertise and contribution to the workplace has won him numerous awards and accolades, both at Cisco System and Wipro Technologies, with which he was associated prior to joining Cisco Systems. It's our honor to have you on board, sir. We extend a hearty welcome to you on behalf of management of Dayanand Sagar College of Engineering. Welcome you, sir. Thank you.
Thank you, ma'am.
Sir,
That's quite an introduction. Yeah, sure, ma'am. Thank you. You're not used to this kind of, elaborate introductions. Thanks a lot. Okay. I just shared my screen. Can everyone see this?
Yes.
Yes, sir. You can make it full screen, I think.
Okay, sure, ma'am. Shall we start?
Yeah,
sure,
sir.
Okay. Okay, so right away, I would like to thank the college management and the organizing committee for inviting me to give this talk. It's always interesting proposition to interact back with the academics when you have moved on to the industry. So there is always this opportunity to learn and give. It's a two-way street. So I really thank the organizing committee for that. Okay, now so what is the significance of a mobile world? So what has happened is as we are going to see in the upcoming slides. So over a period of time, the boundaries have blurred between a stationary world, on-prem world, and the mobile world. So earlier it was like a clear-cut definition. So you used to have mobile devices which were exclusively used outside of the premises. And then you used to have on-prem devices which were always deployed in a customer premises or an organization enterprise. And there was a clear-cut defined boundary. But that's no more true. So the boundaries have blurred. So there is a lot of intermingling of devices and applications and activities between these two worlds. So it's going into a unified world, in fact. Now, okay, so what is more interesting is to start off a presentation with some of the very notable quotes that we have heard actually. So as part of this presentation, I wouldn't want to delve into all the technical aspects, too technical that are going to be part of your academics, the encryption techniques, the symmetric and asymmetric encryption, and and such stuff. But I'll be taking a holistic view of a more realistic world that is happening, the realistic scenarios that are playing out, and what are the ways to address those things. So this is essentially about the public key private key kind of encryption. So basically, what Tim Cook tries to say here is none of the algorithms what we adopt are foolproof. So then the next question here is, what are the ways to address the cyber security issues? So it's not just going to be encrypting data alone is not going to help you. So we need a multifold approach to address this growing menace. Okay, so the first thing is basically about that. Okay, and we all know Stephen Hawking. He was one of those scientists who blended science with philosophy. And this is what he says: I think computer viruses should count as life. I think it says something about human nature, that the only form of life we have created so far is purely destructive. Okay, so this is true with the amount of malicious activities that that happen online. This really holds true. Okay, let's get started. So what is cybersecurity? Okay, cybersecurity as a definition, if you look at the textbook definition, cybersecurity is the practice of defending your computer systems and networks, mobile devices from malicious attacks as well as unauthorized access. It's also known as information technology security or electronic information security. Okay, this is a plain simple definition, but when we start delving into the aspects of it, we see that it's a whole new world to learn. Should we be concerned? Of course, yes. So here is what we have. So this is something which came up recently. The COVID pandemic, which presented to us, unprecedented scenarios, unprecedented situations, also led to some of the serious crimes happening. People exploiting this fear, people exploiting this situation, and as the workforces moved from offices to homes, as work from home kind of strategies were adopted, cyber crimes also increased because a lot of enterprises had invested in securing their enterprise networks and enterprise devices, but they were not prepared for complete work from home shift before this event. So this is something which is an alarming number here. Now, there are companies, there are financial institutions, banks, and some software companies or other organizations which had adopted good practices and other hardening techniques. But this was this came as a shock for a lot of companies. So this is a learning curve, and people have realized it, the importance and significance of cyber security. Now, to emphasize the, so we can never, so whatever statistics I present here, we can never emphasize the importance of cybersecurity. But these are some of the statistics which will, which should alarm us, which should, make us pull up our socks and, to handle this, problem. So this is what we see here. Okay, and wherever I have referred to external data, I have cited the sources as a separate inclusion, or it's part of the presentation itself on the slide. So web attacks worldwide between July 2018 and this year 2020. So basically, in a span of 2 years, so United States has seen about 3.2 billion cyber attacks. So for a country which has a population of about roughly around 350 million, this is the number of cyber attacks it has seen. So if you want to take an average, it's like 10 cyber attacks per citizen. Now that's a really alarming number. So India is not far behind. India is at global rank 3. So we have, so of course the ranking also depends upon the severity of the attack and other aspects. That is the reason we don't see it in the same order as the total number of attacks here. But we see that we are not in a good situation either. So what has happened is, as we have moved towards new payment mechanisms, new like online payment, app based payment, like to realize the vision of our vision of being a cashless economy or less cash economy. So this has led to a lot number of security breaches and security attacks. Now this is really an alarming number. These are some of the worldwide statistics. These are all recent statistics that I'm referring to. Nothing is older than 1 or 2 years. Now, now coming to the next aspect of this. So what is the rate of growth of mobile phones? So this is the 2021, the expectation is that this is only about the smartphones. This doesn't include other mobile devices like tablets or your laptop computers. This is just referring to the smartphones. So you can see for a world which has about 7.5 billion population. So half of the population already has smartphones. So this brings upon this emphasizes, I believe, the importance of cyber security for the entire world, not just any specific country or a specific set of population. And this is something which shows about the growth of IoT devices. So I'm sure we all know what is IoT, Internet of Things. This is basically, so earlier it used to be human beings which interacted on internet using their mobile devices. Now it's the devices that are active on the internet, that are active on that are interacting with each other. So there is no human intervention. It's purely the devices communicating with each other. Now these are more prone to some particular set of attacks. So what happens is whenever there is a human intervention, most of the attacks, if we see, about 45% of them generally happen because of human error. Okay, you either have you leave your device unattended, or you completely have an unsecure password. Such human errors are leading to some of those attacks. But when it comes to IoT devices, the kind of attacks that we see here are very different. It's like taking control, hijacking, such kind of things. Now, why is IoT so significant? IoT is significant because we are connecting more and more devices. Like if you look at the scene in India, if you look at the car market in India, about 10 years back, there wasn't a single car which was connected to the internet. Now we have almost every manufacturer whose car is now connected to the internet. So we don't know what's happening there. We never get to know that. Car speaks to the service centers, it sends the telemetry data, statistics, kind of thing. So all this kind of data. Now, the next phase of the IoT devices, especially coming to the transportation, is autonomous driving. And there are different levels in autonomous driving, basically. One of them is that you have cars which identify that there is a collision ahead and I have to slow down, all this kind of. How is this enabled? This happens purely because of the cars are able to interact with each other. There are protocols being developed for this. Either they interact directly or interacted through some web service or cloud service. Now, what has enabled this kind of device? So earlier what happened was the previous generation of mobile networks. So the biggest challenge with them was the lead time to initiate the communication, the lag. So now with 5G in commercial adaptation, so this has reduced. So there is a very minimal lag time between your start of communication and sending of the data. So that has led to a lot of other computer to computer, device to device communication possible, and this has led to the explosion of IoT adoption. Now, we saw some of these statistics. Now, let's look at some of the most audacious web attacks in 2020. So I'm very sure most of us already know about this, but I would like to bring this here just to make sure that people who haven't already been aware of this, get to know this. Now, this has to be the one. This was so audacious, it came into limelight immediately. Okay, so few months back, we saw that a lot of global figures like Elon Musk, Barack Obama, Bill Gates, and even companies such as Apple posted identical tweets, okay, which claim to be supporting the cryptocurrency Bitcoin, and then mentioned that an account number was given below, Bitcoin account number, and saying if you transfer certain amount to that Bitcoin account number, you will get back double the money. Okay, and this was done by the verified account. And look at the audacity of this attack. This was a pinned tweet for Jeff Bezos's Twitter timeline. Okay, now the people did so, but the only disadvantage this whole attack had was because it was so audacious, it involved so high profile personalities that it immediately came into attention, and Twitter acted on it by disabling all the accounts and started the mitigation activities. Now if this was at a much lower level, the damage could have been very severe. Okay, now some of these attacks are purely to gain notoriety. The intent behind the hackers or the malicious accounts doing this is purely to gain notoriety and become famous, in their own thought process. Now we see the damage was done already. 130 high profile accounts were affected, and they all tweeted pretty much the same thing. So what we see here, Jeff Bezos, Elon Musk, Apple, the same tweets went away. Almost pretty similar tweets were sent from about almost 130 high profile accounts. Okay, and people fell for it. People actually transferred the money, bitcoins, to the account mentioned here. If you see at the bottom of this tweet, you have these account numbers, right? So these are Bitcoin account numbers, and people did transfer their Bitcoins worth almost 110,000 US dollars. Okay, and that money was gone. I mean, you could never recover that. So that was gone. And what was the modus operandi? So it was basically social engineering to gain access to Twitter admin tools, and they started hacking these IDs and started posting all this kind of tweets. This, if we remember, there was a similar attack. I mean, popular modus operandi a few years back, which was very popular. Somebody would send an email saying they will impersonate as your friend and say that, okay, I was traveling and I'm stuck in London. I don't have money. I lost my wallet or whatever. And then please transfer me money. I'll return it back the moment I'm back to Bangalore. How was that done? That was basically done by, scouting through your social media profiles and trying to see who are your friends, how do they interact with you, do you have very personal relationships with them, whether it's possible that you will transfer money if they ask. So all that kind of things they did, and even out of like 100 attempts, one attempt succeeded, they would have made their money. So that was a little older way of doing it, through the email. This was a more audacious attack, and this took everyone by surprise. Even Twitter CEO Jack had to come into picture and explain what was going on. Okay. Now, second was the New Zealand Stock Exchange. This was basically a distributed denial of service attack. Basically, what you do is you flood your web services, if they're not protected, with so many number of requests that your legitimate services and legitimate requests get affected. So that is simply denial of service. It's like flooding your streets with vehicles from some unrelated place or some unwanted rallies and all. But then what happens is the legitimate traffic, legitimate people will have no service bandwidth to utilize these services. So that is what is called as a distributed denial of service. Now, what happened? New Zealand Stock Exchange was completely down for so many days during August and September. So trading halted, transactions had to be rolled back. Okay, some transactions which got stuck midway needed manual intervention, where automatic rollback was not possible. So as a result of that, recovery took a while. Okay, so this was one of the other. All this happened in 2020. So all the attacks that I'm referring to. Now back home, we had a big basket customer data breach. What happened? So user data belonging to 20 million customers was available on dark web actually, and it was being sold for about 40,000 US dollars. Details included your personally identifiable information, email IDs, phone numbers, and such, Aadhaar card number if you have given, and all such details. What happened? The damage was that loss of reputation for big basket, loss of customer confidence. Customers were, you always have this when you face this kind of attacks. Customers always face this kind of lack of confidence. Basically, they trust the enterprises that little more less. Okay, and modus operandi we never knew. Indian companies are never forthcoming in declaring what has happened, but foreign companies, because they are forced by regulatory mechanisms and stock exchange regulatory mechanisms to declare everything that goes on. since we don't have any such very strong laws and dealing with this kind of attacks, and it was not a listed company, big basket, so we never know what was happening. But the conjecture is that the brute force attack was suspected with possibility of human error in handling admin credentials. Okay, so these are some historical laurels. We all know what happened with Stuxnet. Basically, the entire nuclear system of Iran was sabotaged by some hackers. This attack developed over a period of 3 to 5 years. It was a very targeted attack. The hackers were aware that nuclear plants in Iran use Siemens-based machinery, and so what they did is they produced these virus which will affect only those kind of devices which have those basically Siemens hardware. And then what they did is they just took a chance and started spreading the virus. So what happened is, it took a while actually, and they were just hoping that somebody will infect some computer in Iran, and somehow that computer will get somebody will use that who is a regular user, and then he connects it with a USB drive or something with the nuclear network of Iran. And that is the reason it was not thought through a week or month. It was it was a project that extended into years. But ultimately what happened, all their centrifugal devices which were sourced from Siemens, they malfunctioned. It was a huge loss for Iran, but that was what the hackers were intending. So that is something which we saw. It was very famous actually. And then the other famous was the crypto locker, wherein your devices, your entire data will be, this malware will encrypt your entire data, entire hard disk, and then it's a ransomware, and then your a message will pop up on your screen saying your data is lost now. If you want to recover your data and decrypt it, then you'll have to pay some amount to this basically hackers. They'll have ways of transferring it online, and a lot of people did that. And some enterprises which had very strong security, they could recover their systems. Healthcare institutes were affected, individual users were affected. This happened about like 2 years back, crypto locker. So a lot of such cyber attacks we have seen earlier. Okay, now coming to understanding cyber attacks. So there are different parts of a cyber attack. When cyber attack happens, it doesn't happen at a single site. There are different sites actually. So one is the backend sites, that like data centers and backend office systems. So here we have business APIs which are exposed, or we have vendors working and they need access to these backend systems. So those access systems are not hardened. Because of that, all these data centers and back office systems are vulnerable. And then communication channels. So we have communication channels. We have two types. One is the customer premises communication channels, and then public communication channels. With the advent of public Wi-Fi, now there are Wi-Fi hotspots available everywhere by service providers. So those are vulnerable. Cellular networks are vulnerable. Internet itself is a very vulnerable place, and customer premises devices itself are vulnerable. Then local networks, if they're not hardened, personal Wi-Fi. How many times have we not seen if you log into your home router, you would have sometimes seen the count of clients which are being served by that particular router is more than the number of devices that you have in your home. Then you start suspecting, is somebody from my neighborhood using my Wi-Fi network? So these kind of challenges, these kind of intrusions are a real challenge. It's a challenge because if somebody uses your network to do malicious activities, you could end up in legal trouble. Okay, first of all, you are not getting the promised bandwidth. Your bandwidth is being shared with some freeloaders. Okay, and if they use these networks for malicious activities, then you are at risk, legal risk as well. So there are a lot of challenges with that. Okay, and then the other threat site is the device itself. The device itself is so vulnerable for hacking, and because of that, the apps and the your browser and other services from your app can be from your mobile device can be hacked. Attack surfaces basically are defined by points or vectors, attack vectors, which are the routes through which attacker try to enter an environment. Okay, the idea as part of cyber security is to harden all these entry points and make sure that it becomes so much more. None of these techniques that we are going to discuss is going to be 100% foolproof. So what we try to do is we have so many security mechanisms that one or the other way we get protected, and that is the whole idea behind having a holistic security model. Okay, so we have seen all these things: compromised credentials, weakened stolen password, malicious insiders. Sometimes insiders itself uh, actually try to sabotage, missing or poor encryption, misconfiguration, ransomware, phishing, trust relationships. Zero-day vulnerabilities is basically even before your device and network has been hardened, you are just setting up your network, and at that moment itself it becomes vulnerable. Okay, and then the most classic, which has been there right from day one, is the brute force attack. You keep guessing, saying this is the password, or this is the credential, or this is the key used for encryption. So a lot of ways in brute force attack. And then distributed denial of service. The last two are the oldest type. They have always been in place. They have always been put in practice by hackers, and these are something which should worry us. Because even to this day we don't have a guaranteed solution to stop these kind of attacks. Okay, so here we have different attack types. Basically, these are some of the most popular attack types. The phishing, a man-in-the-middle attack, SQL injection, cross-site scripting, DDoS, password attack, AI-powered attacks. Again, the password brute force attack are now becoming more and more smart. So it was earlier, it was what used to be a brute force attack has now turned into AI-powered brute force attack. So this is really concerning. So we have seen some of these happen. And then drive-by attack, ransomware attack, eavesdropping attack. So some of the most popular ones here, the phishing, where you send an email, innocuous looking email saying, can you please update your so and so, and then you send a link, and then when you click on that link, it takes you to some website, malicious website, and then you are made to reveal your information. And the other types of phishing attacks are the hackers will share a link. For example, if they're trying to hack target customers from SBI, they will design a page which exactly looks like an SBI login page. Okay, and even the URL will be almost similar like a SBI. For example, if SBI online is the URL for SBI bank, so they will have something like SBII online or some with a very minor variation, which is very difficult to notice especially for newbies, and then share that as a link for your login activities or online activities. And what happens is you open that link, and that page looks exactly similar to an SBI login page, and then you enter your credentials and click submit. And then there is an error which says so the online banking is not available at this time, please try later, or something of that sort, which will which will not arouse any suspicion. Then what happens is you have already submitted your credentials, and those credentials would have been captured by those malicious actors, and then they will use those to log into your accounts and basically operate. So now to overcome all these things, there are ways to do that. We'll see how it goes. And then there is a man-in-the-middle attack. Man-in-the-middle attack is nothing but intercepting your ongoing session and then trying to send your own data. So man-in-the-middle attack and SQL injection can happen in tandem. Basically, you intercept a REST call and then replace some of the queries there with your own queries, and then you can you can harm the target system. Now, distributed denial of service, we have already seen. Cross-site scripting is basically, so what hackers do is they target some of these websites and try to inject some of their own code as part of the web page. So the web page looks normal, and then what happens is in between at some point you see that there is a a frame or something running code from some other website. You will not even realize that. And then when you are interacting with that website or entering some credentials, you might feel that the small part of that website which is actually from a different hacker or a different domain, you feel that it's part of this main service itself. For example, if you open cisco.com, and if the Cisco homepage is not secure enough, what happens is in between somebody might inject this cross-site scripting JavaScript code, and then that will play up. Okay, and then a person who is looking at this page will see that okay, I'm looking at cisco.com, and whatever code I'm seeing on this, whatever fields and forms that I'm seeing on this page are entirely going to cisco.com, and then try to enter some data. These are all cross-site scripting attacks, and there are mirrored cross-site scripting attacks also, which are similar. But what happens is you actually mirror it from the service itself and not directly the desktop, the client browser or client machine. So those are cross-site scripting attacks. Okay, and eavesdropping is basically listening on to your conversation. You may not act on that. Okay, and you just listen to what's going on and then make use of that information to further your own other agenda. Ransomware attack is similar to what we saw earlier, the crypto attack, where the malware would encrypt your disk with their own keys, and then it becomes impossible for you to extract the data. And then what they do is they will ask you to pay some amount, and then they'll decrypt it. That's one example. There are different examples of ransomware. Basically, they try to put you in a situation where you are forced to make the payment to recover your system. So those are ransomware attacks. Now, this is the typical anatomy of a cyber attack. Okay, so it consists of the following 7 components. Reconnaissance: basically you gather information about the target and try to understand the behavior and the system of the target, and then try to model your attack on that. Weaponization is based on your reconnaissance. You would have already found the behavioral loopholes, or some loopholes, and then what you do is you target those particular loopholes using a particular method, and that is called as weaponization. And then delivery is basically sending this. For example, if you have created a ransomware and then you have identified that there are open ports on a particular system, and then you try to deliver your malware through those open ports. Exploitation is the actual playing out of the attack when the user realizes that something is wrong with the system. Installation is when is only relevant when you are installing a system. When you are installing a malware or a virus on that, there are systems where you just take control of it with brute force, and you change the credentials, or or all such things are possible. Where installation doesn't come into picture. It's only exploitation, then command and control. Command and control is basically when your system is under the malicious actor's control. So either it's encrypted or credentials are changed, or in whatever way it's under the malicious actor. Now, as part of the actions, what they do is they try to blackmail, or they try to extract ransom, or they try to sometimes the intent is purely to create damage and havoc. So that is what happens during the action stage, and the intent is also to keep the control as long as possible and not lose it immediately. So this is the anatomy of a cyber attack. And who are these actors and what are the motivations? So if you look at the typical attacks that have played out worldwide, so some we can categorize roughly into a few of these groups. Cyber terrorists, the goal is to harm and destruction to further their own cause. Motivation is political goal or military agenda. And then there is government state sponsored actors. So most of the times this is espionage, theft, or any other activity that furthers the interests of a particular nation or group of nations. Most of the times it's political or national security that is the motivation. organized crime, almost always the goal is always the financial gain, and motivation is also the financial gain. Internal user errors. So basically, this is something where there is no goal and there is no motivation. It's basically bad, bad security hygiene. People don't have strong passwords. People are prone to leaving their devices open, accessible, and unlocked. So these are internal user errors. And some of the other ones are hacktivists, basically. So we have seen this play out, like we see that sometimes a particular country's national website is damaged, and say that, okay, you have been hacked with by this particular group or so and so. And then there are political, social, and basically any other activism related to a cause. So the intent here is not to damage a system. The intent here is that we are here, we are watching you, and we have this particular agenda and we are working towards you. So it's more of a sending across of a message to a larger audience and to gain some fame. So that is mostly what happens with the activists, hacker activists. And some of the threat actors are insiders. So this is basically how an espionage works. You pay off a worker from some other rival organization to extract some data, so which is easier for him to get access to. If you have to hack a data system from a rival organization, it becomes so much more challenging, because there is a physical barrier. But if you can get an insider to do that, so one barrier is already crossed. So those are some of the insider actors, and the motivation is it's financial revenge and espionage. And then we have script kiddies. These are budding attackers. They don't develop their own tools. What they do is, most of the times, they utilize the tools that are available and then create as much as damage as possible. So the motivation is nothing but notoriety and fame. And these can be the actors which are easily dealt with. So they're not very challenging. They just try to hack system and create some havoc. That's all. Okay, and what is the loss we see when we have this kind of activities happening? So as a company, government, state, or enterprise or service provider, you have your loss of reputation and damage to brand, loss of customer side confidence, and theft of unauthorized data because of unauthorized access, IP loss resulting in losing competitive advantage. So you might have filed your patents and kept them on your internal IT systems. Somebody gets access to them, you lose that competitive edge, and they know that what you're coming up with. So if your future product roadmap is there on your systems and somebody gets to know that, that's a very valuable information for any organization. And then there is PII leakage, personally identifiable information. There is espionage. There is state secrets, which the governments keep. Every government has its own state secrets, actually. So why they do certain policies, how to deal with foreign relations and all this. So we have seen this classically in case of WikiLeaks, when Edward Snowden and his team, they revealed so much of intergovernment communication, intra-government communication, leading to a lot of embarrassment for a lot of countries. And then there is financial loss, direct monetary loss due to litigations, because you for example, you have your own customers data, and because of your security flaws, and that data gets exposed, those customers might sue you. So you end up going to courts. There is a lot of litigation cost and loss due to litigations also. So that's a direct financial loss. So as an individual, again, if you have been ever attacked, so you might most likely have lost the money. So we have all seen how some of the attacks have played out in India, where you get a call to unsuspecting customer, mostly elderly people, saying your debit card has been blocked, or your account has been blocked. If you want to activate, you do what I say now. I am calling from so and so bank. And then the unsuspecting elderly people, or people who are not aware of this kind of attacks, they fall for it. They reveal their OTPs, and then they see that their account has been cleaned off. And theft of protected health information is a real challenge. We have seen a lot of ransomware attacks happen on health companies, on hospitals. The reason is because there is a lot of the customer health patient health information is strictly a confidential information, which is supposed to be known only to the doctor and the patient and the close family member if the patient approves. Nobody else has any business knowing that information, because that could be used for a lot of other malicious activities like blackmailing or destroying reputation, a lot of other such malicious intents. And further misuse of data resulting in crimes like blackmailing. So this is what I was referring to earlier when we talked about PHI. Now, coming to preventing cyber attacks. So these are the 5 principles of designing secure systems. Establish the context before designing a system. Before you can even create a secure system design, you need to have a good understanding. We see in the upcoming slides how we build a threat model, and then what are the steps involved in that. So basically, you establish the context. Now, make compromises difficult. So as I already mentioned in the previous slides, it's really impossible to claim that your system is 100% foolproof. So that is not possible. But what we can do is we make the compromise very difficult. And then make disruption difficult. For example, if your system is prone to DDoS, now if you see that a particular type of it's only one type of request that is repeatedly coming in, you can build your intelligent systems where those analyze if they are originating from the same origin, if they are trying to access the same resource, and then try to block such requests, or hold on to such requests and block them at a higher level. Not let them into the system, okay, and try to flag them off so that a manual intervention is required if it's a genuine request or if it's a malicious request. So making disruption difficult is one goal. Make compromise detection easier. Basically, even if your system is compromised, you should have ways of identifying that, flagging that. These are very difficult to design, but there are ways where we can design such systems. And then reduce the impact of compromise. Basically, if you have compartmentalized your data, compartmentalized your processes, and then make sure that your processes run in their own sandboxes, any damage or any compromise happening to one process will not affect the entire system. So we can isolate we can basically isolate this whatever compromise that has happened now. Now, as I was referring to earlier, threat modeling is an important step in in designing a secure system. Basically, it's a pen and paper activity. That is, you start off threat modeling right at the start of your project. So you don't wait till your system is ready to do threat modeling. Threat modeling starts with the design requirement phase itself. When you start thinking about a system, IT system, whether it's a on-prem system or a mobile device or any IT system. So you start off with threat modeling, okay, and basically you try to identify what are the possible loopholes here, and what are the possible surfaces where a threat can come from, a vector where which can be used as a which can be used to compromise the system. So you identify all those and then see what mitigation plan you have for each of these components. So that is what basically entails in threat modeling. I have a couple of examples in this slides that are going to come up. We'll see how we do it. Okay, so this is for a typical web application. So web application is basically a customer is accessing an application from some remote device. But what is happening is your data and service is running on a server which is at, say, enterprise enterprise data center or enterprise labs. Now there are, if you look at this particular image, so this has various assets. Okay, assets can be on the client side or assets can be on the server side. And then we have various controls, basically the mitigation mechanisms. And then we have threat agents. So what is the threat at each level? Now, if you look at taking one example of TA01, so TA01 is a malicious app user. So what basically happens here is you are using a browser, but then if you have a malicious basically a ransomware or any other virus which is which sneaks into this particular website, you have the possibility to compromise a lot of things there. You can compromise the credentials, you can compromise the personal data, or you can compromise the entire system itself. So this is how this pans out. Now we see that there are like network attackers, malicious websites, malicious client software, user with physical access to a session. So basically TA05, if you look at this threat agent 05, it is something which we already referred to as insider espionage. Basically, you get hold of somebody inside an organization or inside a company or inside a system, and then use that person to play out your attack. So this is most of the times it is a espionage related agent, but it's an insider. And so this is for a typical web application. Now we'll see, since our emphasis is more on the mobile application, so how it looks like in a mobile world. So pretty much it remains the same. Threat agents remain the same, controls remain the same, assets remain the same, except that the boundaries are defined in a little different way. That we are going to see in the table in a couple of slides that are going to come up. Basically, you have a mobile device, and if you're we have always seen this. So if you recall, you install an application on your device, it asks for permission to your contact list, your camera, your basically pictures and files. A lot of people don't realize whether it's really important for that application to access that or not. So they keep on saying, okay, accept, and then see that the app is really able to access all of those resources. So the popular mobile operating systems like Android and iOS, they have these mechanisms where as a user you have the control to allow access for those applications to certain resources or not. For example, if you don't find that a particular application needs access to your contact list, you don't have to really give that. So what happens is, if assume that you are installing a software from an unverified source, okay, and you give access to your contact list. So now what happens? So that particular software can send messages, calls, or because it already has contact information, it can play out a certain number of different types of attacks, okay, with that contact information that is available. Now if you give access to photos and files for an application which really doesn't need an access to photos and files, and if that application turns out to be malicious, so what happens is that can be uploaded to a remote server, and then you see that your information which was supposed to have been private becomes public. We have seen a lot of personal photos getting leaked online. So all that happens because people were really either not careful with what applications they have, or their device itself was compromised. So there are different threat agents here. So getting physical access is of course one easy way to prevent, where you take care of your device. But when you are using your applications, when you are using unknown applications, when you are installing new applications, it's very important that people are aware of what all that application is accessing, and can we limit its access boundaries, basically make it run in its own sandbox. That's how most of the applications are written. But then don't allow access for it to don't give permission for it to access other resources like files and photos, or your call records, or your contact list. So those are some of the things which play out in a typical attack. So this is how threats play out. And then we have threat agent, malicious app user, attack surface is browser, target is application functionality, JavaScript. How do we prevent it? Basically by obfuscating the JavaScript. So you don't give there are ways to prevent your script being used by by some other browsers, by some other malicious softwares. So those controls can be built in. And there are, for example, if you look at malicious websites, and then browser is the attack surface. Basically, malicious websites attack through browser. The only reason, because that's the only way they can get into your system. Okay, and what happens is here, so you have your same origin policy. So same origin policy can prevent cross-site scripting. So browsers know that what information they are loading. Now, if you have a same origin policy, hardened on both the client and the server side, so what happens is the browsers identify that in a particular given website. I gave an example of cisco.com. So if some other domain is trying to inject a particular script to run, so the browsers itself are smart enough nowadays to identify that and block it. So you can try it out actually. If you have a browser and then try to insert try to open that browser and then try to run a script inside that, which is referring to some other domain, it will block. The browser will eventually block it. So, but only thing is your same origin policy and such things should be in place. Input validation and output encoding, basically this refers to submitting form data. You have to make sure that input validation is done, because you can prevent SQL injection attacks, as well as where you basically end up inserting some control characters and then bringing down the whole system. So all those can be avoided if you are doing your input validation. So this is for typically for web apps. Similarly, we have for mobile apps, there are different, apart from what is there, what we saw in the earlier slide for web apps. So this is an add-on to those entries there. Here, the threat agents are additionally malicious app users, malicious apps. And then we have what is the attack surface is shown here, the browser, mobile device, and then target assets. So how do we control it? So as we discussed earlier, if you look at the second entry here, malicious app, mobile device, it's a threat surface. Target assets are application data, application functionality, cookies, users' private data, device functionality. Okay, and app sandboxing. If your app is made to run in a sandbox and and we enforce the permissions to access the other resources of the mobile device, you are pretty much safe there. Even if it's a malicious app, it can do no harm, and once you realize it's malicious app, you can always uninstall it. But if you're already given permission for it to access file system, it can install additional malware on your system, and then it becomes very difficult for you to recover your device. So security, if you look at security of system, mobile or otherwise, so there are different perspectives to look at it. So one is, as a developer, how do you write secure applications? As a systems engineer, how do you design secure secure systems? And as a user, how do you keep your system secure? So whatever we are doing here, so it's mostly from the first two aspects, the systems engineering and software development perspective. And as part of that, secure application development is a very important step in securing your systems. So what happens is there are steps here. You have basically write secure code. Bugs and vulnerabilities in a code are the starting point. So there are CV website common vulnerabilities and exposures, so which are regularly presented out. So you go and check if you're one of the libraries that you're using has any CVE, and then see if it can be patched and update your application. So all that is possible. And there are, if your code is not secure, so what happens is your code can be reverse engineered, and somebody might tamper your code with their own malicious activity and post it as a separate app. So now what happens is it looks like it looks similar to your app, but then there is a malicious code inside that app which is running. And then what they do is they basically play out a complete havoc with the systems that install such apps. So this is a very common threat actually. So that's the reason they say whenever you are installing an application, source it from a very secure this one. For example, for Android applications, we are used to directly downloading APKs from third-party websites and then installing. So the problem with that is we don't know who has written that APK application. If you are downloading it from Google Play Store, so Google would have done their some preliminary assessment before allowing a particular user to post their app, and it's easy to rate there. It's easy to mention any problems that are identified, so it becomes much more easier to control your applications. But if your code is not secure, what happens is some people, third parties, might take that code and modify it with a malicious intent and then post it as your app in a public place where people can download it. So that's a real challenge there. Encryption of data, of course, we all say encryption is a very important aspect. This is the most preliminary security technique. We all need to encrypt our data. Be extra cautious with libraries. As I was telling earlier, when we use third-party libraries, we should be very sure that the libraries are sourced from verified sources, and that we have support available in case of any vulnerabilities are identified. And then use authorized APIs only. Of course, if the APIs that aren't authorized and loosely coded can grant access to hackers to do other things apart from what it is intended for. And one of the other important aspect is that multi-factor authentication. So multi-factor authentication is nothing but you have two levels of authentication. One is, for example, if you're logging into your banking website. So we used to have a hardware security basically device where first you enter the password and then you generate a live password and then enter that. So here what happens is in two-factor authentication, one password, even if it's compromised, the second password, if the device is held with you, people cannot basically access. So in India now, for example, banking systems are all two-factor authentication. You go and try to do a transaction. You first log in with your login password, and then go with the transaction password. And then what happens? It generates a OTP, one-time password. So this is basically to prevent any malicious attacks. Multi-factor authentication, now it's becoming popular even for regular applications. So Cisco has a product called as Duo, which provides this multi-factor authentication. So there are other companies also which provide this. So basically you can integrate the apps with such systems to get the multi-factor authentication functionality. Okay, now the other thing, the next secure application development step is, to create tamper detection technologies. Basically, you can write some self-verification mechanisms wherein if it identifies that your code is being tampered, then the application wouldn't run. So these things are possible now. So like for example, most of the times what happens is when we ship our commercial software, we encrypt it with a particular private key, and if we have the corresponding public key with on your system, only then you will be able to install it. Otherwise, it's not possible. Sorry, we encrypt with the public key, and if you have your own private key, which is given to you, only then you will be able to install the software. Principle of least privilege is again something similar to what I referred to earlier. Basically, when you install an app, you should really think whether that app requires permission to a particular resource or not. Similarly, as an app itself, you should code in such a way that it should run with only the permissions that it requires and no more additional permissions. And the other important aspect is that session handling. So when you write applications and there is session management involved, most of the times when you close the app, the session remains open, and the next time you open the app, it relaunches. So while that looks across as convenient, leaving sessions open could make way for a lot of attacks like man-in-the-middle attack or session hijacking kind of attacks. And of course, the ninth one here, what we see here, use best cryptography tools. This everybody knows. So earlier we used to have MD5 and SHA-1 as hard enough for any system to encrypt with. But now we have seen with hardware speeds increasing, brute force attacks increasing, MD5 and SHA-1 are no more secure. So to stick with the latest one, now the 256-bit AES encryption and SHA-256 are used for hashing. And nothing beats above all of this proper testing. Nothing beats proper testing, thorough and repeated testing. So basically, if you have tested your system like you would, for example, think from a point of a hacker or a malicious actor. So what does he want to do with my system? So if we go on those lines and then test your systems, you will be able to prevent a lot of attacks, and that could happen on your system. So now whatever we saw earlier was basically about the security in software. Basically, when you are designing a software, you have some good practices which allow for a secure system. Now there are, so with increasing mobility and with increasing complexities, so a lot of security is getting built inside the hardware. For example, Apple has introduced its T2 chip. It's almost 4 years old now, and Samsung has the secure element chip here. So basically, they do crypto processing. So earlier, what used to happen on software at a software layer now happens at a hardware layer. So that makes it much more difficult for it to be compromised. So earlier, it was possible that your encryption algorithms itself would be compromised. Now that is not possible, because your public key is encoded on your system, and then your chips are made to use only that key to do encryption. So the entire encryption logic is on your system, and it resides in immutable memory, basically. So what it does is it enables secure booting, because most of the systems can also be hijacked or hacked during the boot process. Now what happens is, by verifying the boot software with the public key encrypted in the immutable boot ROM itself, it becomes very hard for taking over a system at the time of booting. So 0-day vulnerabilities are addressed with this kind of secure boot systems. And there are systems, secure systems, where your in-memory content itself is encrypted. So even if some malicious app gets access to transcends its boundaries and gets access to your memory, that is the running memory. It's not the it's not the device memory or the storage. It's the primary memory that I'm referring to here. So that itself can be encrypted. Of course, we always have concerns around if you have the running memory encrypted, is it going to slow down the system? But with the improving hardware and improving systems now, so that's no more a concern. So what is more concerning is that there are malwares which can actually read into your memory and then try to make sense out of it. So all those things can be protected if you have a encrypted memory content. Okay, so now coming to the other aspect of securing your devices. So there are services which help in securing your devices. So basically, these are based on either DNS query interception, routing traffic through their own VPN, or routing traffic through their own proxy, or on device policy enforcement. So what happens is, suppose you have there are examples for that. For example, there is a software service from Cisco. It's a cloud delivered security service. It's called a Cisco Umbrella. So we'll see the examples in the upcoming slides. What it does is, it basically, the moment the first DNS query happens, it actually rates the DNS, it resolves the DNS and then rates the DNS destination to ensure that the device is accessing the secure service. Or a safe service or an approved service. You can create profiles, you can do a lot of things with that, and if one of these things is violated, it will flag it down. For example, if you try to open a malicious website, it'll just say that your current policy doesn't allow you to open this, because this particular website or this particular app service has so and so issues or threat concerns. These services are cloud delivered, and they are getting extremely popular now, especially in enterprises. These are enforced, because now with all the bring your own device or such kind of such kind of policies in place where you can carry, instead of using your office computer, you can carry your own laptop or you can carry your own handheld device. But how do you secure it? Now, what you do is you download your security profiles on your device, and that profiles are controlled by your basically enterprise. Now, what happens is if there is any violation of that policy that is enforced on your device, it'll flag it down. And what it does is it will not allow such applications to open, or it will not allow such websites to open on those devices. So these are some of the very popular security services. Cisco Umbrella is one. So this Cisco Umbrella is something which I was also part of. We had it included in one of our network management solutions. What we did is, as part of your network hardening, we could enforce the Cisco Umbrella policies on all the devices managed under that network. And then what happens is you don't have to configure devices individually. Any device that is part of that network will automatically be made secure. Of course, none of the security systems can be foolproof, but this is one of the most popular security systems now. So McAfee has web protection, Zscaler security, and then ForcePoint are some of the other security services which provide a great level of security to your devices, mobile devices as well as your on-prem devices. Okay, so this was what pretty much we covered. We try to see what is the threat perception in the current age in the mobile world. What are the ways to address it from different perspectives? So of course, user perspective, it's always to have a secure password, alphanumeric password and all those things. But apart from that, as engineers, what can we do to do create secure systems? So that's what we try to address here. Since that it's more about industry interfacing presentation, I have tried to cover as much from what are the latest trends and how we are trying to address them, rather than most of the academics, like academic aspects like the encryption algorithms and all, which are a topic in itself, which will need a dedicated session if you have to do that. Now, this is a I'm sure people know John Chambers. He was the CEO of Cisco Systems for like 20 years, and under whom the company grew from $1 million company to $1 billion company. And he made this very funny observation. There are two types of companies: those that have been hacked and those who don't know yet that they have been hacked. So basically, everybody has seen compromises, IT system compromises at some point. And it's just that people don't realize that they have been compromised most of the times, and that is the most unfortunate thing about cyber security. So as much as this holds true for enterprises and companies, it also holds true for individuals who are having their own mobile devices or on-prem devices. So this is something which we need to ponder on. And threat is real, and it's happening now as we talk here. There are new threats that are being created. Okay, so that was it from my side. I'm now open to take questions if there are any.
So that was a wonderful session, Mr. Kadri. Data security is the need of the hour, and
it is, ma'am.
You have given, and you have given a real insight to what it is about and how things can be had or resolved. Though not everything is foolproof, we know that, but at least some insight into it would definitely help. So now the session is open for questions. Anybody in the audience want to ask any question to Mr. Kadri, you would be glad to answer. Anybody from the audience? Either you can type your question in the chat box, or you can unmute yourself and go ahead with the question. I have a question here in the chat box.
Yeah, sure.
This is from Dr. Rashmi S. From IC. She says, good afternoon, sir. Can blockchain be used as a solution to cyber attacks, particularly a DDoS attack?
So blockchain as a solution to mitigate cyber attacks, I particularly am not aware of this answer, ma'am, but I'll get back to you with this answer. Probably I'll need to consult with my security experts, and then I'll let you know.
So Rashmi ma'am, that would have, he will definitely, get back with the
Sure, ma'am. Yeah.
accurate details so that it'll answer your question.
Yeah.
Thank you once again, Mr. Kadri. It was really a wonderful session. I know it's really scary when we hear these types of attacks, and when especially for the novices,
True, ma'am.
yeah. So thank you so much once again.
Thanks a lot, everyone. Thanks for being patient through this presentation. Thanks again. Have a good day.
So we now will be heading towards the track sessions. Individual paper presenters can go to their respective tracks, and they can present the papers there to the session chairs. Links have already been sent to you all. So please log in there, and I request all of you to log back to this Zoom link, to the very same Zoom link at 2:30 for the last plenary session of the day by Professor Ram Ramanathan of UK. So I kindly request all the participants once again to see that they join back on the same link at 2:30 for the last plenary session of the day. Thank you all. You can proceed towards the individual tracks. All the very best, and thank you.